Aeolian winds have shaped this world over immense timescales, shifting dust particles at a rate of fractions of a millimeter each year. Bathed in ochre light, the terrain experiences temperatures ranging from -100 degrees Celsius to thawing conditions, all under extremely low atmospheric pressure. But what forces created such dramatic temperature swings? The rover is now interpreting the environmental conditions of a long-vanished era, each rotation of its wheels representing the passage of geologic time. The atmospheric pressure, at 7.5 millibars, represents a fragile equilibrium, potentially enabling complex chemical reactions. Look closely. The story of Mars is etched in stone. Here, the landscape bears the marks of constant erosion by Martian winds, with dust perpetually airborne. Ancient bedrock reveals the history of Mars, built up over millennia. This conical hill embodies immense geological time, shaped by processes unfolding over epochs. The surface of this rock remains at an average of -62 degrees Celsius, yet its chemical makeup suggests a past when Mars was warmer and wetter. At 7.5 millibars, the atmospheric pressure is less than 1% of Earth's, creating conditions hostile to most known life. But might life exist here, in forms beyond our current understanding? Despite this apparent stability, the surface is vulnerable to wind erosion, gradually reshaping the landscape. Notice the faint lines etched into the rock, traces of dust carried by the wind. These markings reveal the power of the atmosphere, slowly sculpting the terrain over vast periods. The sun's gentle light creates long, muted shadows, emphasizing the subtle contours of the land. The low angle of the sun underscores the planet's profound isolation. Despite its apparent barrenness, this landscape holds the promise of profound discovery. During the summer, the surface can reach 20 degrees Celsius, only to plummet to -100 degrees Celsius overnight. This extreme thermal stress weakens the rock, driving fracturing and erosion. These angular, weathered stones are fragments of larger formations, shattered by impacts. Analyzing their composition allows us to understand the origin of the original rock. But what cataclysmic events scattered them across the surface? It is a lasting marker in a world transformed by slow, relentless change. The rover's journey is a fleeting impression on this ancient land. Its exploration yields valuable data, yet leaves little trace on this enduring terrain. This panorama reveals a world shaped over immense timescales, its dust holding the record of Martian history. Each grain tells a story of ages past. Ancient pressures birthed this terrain. Now the wind continues to sculpt the granular landscape, a constant reminder of time's relentless power. Billions of Martian days of wind erosion have formed this iron-rich, desolate landscape, subtly reshaping the terrain even beneath the rover's wheels. Millimeter-to-meter-thick sedimentary layers record planetary history, revealing past conditions and the possibility of liquid water through their mineral composition. But what secrets remain hidden within these layers? The surface experiences dramatic temperature shifts. The rocks themselves endure compressive forces exceeding 1 gigapascal. Look closely. Evidence of enduring strength against the immense pressures of space. The ancient bedrock suggests a turbulent geologic history. Millennia of history lie preserved in this granular surface, illuminated by a soft, reddish glow. But this beauty conceals a profound stillness. Imagine the consequences of liquid water on this barren world. But how could such pressure build within a world of this scale? Subtle variations in color hint at different mineral content. These jagged fragments bear witness to a turbulent past, collisions and shattering impacts. Their keen edges mark the slow march of geologic time. The atmospheric pressure is just 7.5 millibars, allowing dangerous levels of radiation to reach the surface, equivalent to approximately 200 chest X-rays each year. The conditions here challenged every expectation, a landscape so open to the cosmos. Consider this panorama. Billions of years have passed since these reddish plains last felt the flow of water, yet its passage is recorded in every stone. But how could such a desolate place preserve evidence of a wetter past?